Okay, so I have started and created a blank 3D scene, and you should do the same to follow with this tutorial. So what we're going to do now is I'm going to import an asset. So I've gone to the asset store. You need to register. I have then gone on to here. I typed robot, but it ended up giving me a sci-fi drone. I looked for free because I'm not paying for it because I'm cheap like that. So I want to add this to my asset. So I click on that, accept it. It's going to ask me to go to assets, and I'll go to my assets in here. Window, asset management, package manager. I'm going to find not projects import. I'm going to go to my assets. Now I've got a lot of assets that I've purchased or downloaded in the time, and I've already forgotten what that one was called. I think it was called drone or something. So if I search for drone, there we go. It's in there, and I can click download. Won't take too long. It's only a model, I think. Might have some scripts with it, but I'm not going to use them. No, it's just it's got a test scene, but I'm not going to import the scene. A scene being like a level to think of in Unity. So they've obviously invented some scene. They've probably got some scripts there later to fly the ship around. But of course, I'm going to create them with you, and we're going to do that over the next few lessons. So I'm just going to import that in. So you download it, then you click import. When you click import, it's going to ask me to this dependencies. What that's basically saying is this package needs other things installed. So just install them. It'll probably be some generic things. It needs other probably free packages that might be built into Unity. I don't know, it didn't tell me. And it will come up in a second with the import. And when you import things in Unity, you can select which things you want to import. Obviously, importing it all will just increase your project size. So I'm not going to import all of it. I'm going to not import, for example, the scene. Talk about a prefab later. In fact, I probably won't import that because I can make my own. But actually, no, we'll use the prefab for now. We'll do a prefab in a different video. So I'm going to import everything but the scene. I mean, I could import the scene. I just don't want to. I click import. It's going to import it. And that might take a little while. If it does, I'll pause the video, come back. I don't think it'll take that long. But this is basically bringing it into your project. And try when you're making games or anything with this, try not to sort of import stuff too much, because you want to only import the things you really want to use, because obviously it will massively affect your project size and loading times, other things like that. All right, I'm going to go in here, going to go into the prefab, and in here, I'm going to drag that into my scene. Yeah, I could drag it straight onto there, but you know, whatever. I'm going to hit F, which is going to focus it. Okay, and I'm going to have a look around, and you press play and you should be able to see the drone on the screen quite far away. It's quite small. Also, it could just be far away. I could obviously scale the drone 5, 5, 5, or whatever I want to do it. That's quite big though, so I'm going to leave that as 1. And I'm actually going to move the camera in, and we're going to make the camera follow the object in a bit anyway. So it's not really important to worry too much about moving the camera, because we're going to put a script on the camera that will follow the object, so that, you know, we'll essentially be doing a proper third-person shooter style thing, sort of general gist, maybe a sort of slightly top-down feel to it, but in between a sort of top-down and third-person is what I'm going for, and then it's going to shoot some sort of stuff out the front. But we'll get to that as we go. So I'm just going to move the camera, not the X, that's done. Move the Y down a bit, move the Z much closer, Y down, Z closer, just to so we can actually have a look at it in its natural habitat. Then I'm going to, I can play that if you want. Then I'm going to add a plane. Now this is going to float this object, but I'm going to simulate that by having a collider underneath it, so the collider will sort of float along the floor. But anyway, so there's the drone. I'm going to put in a plane. Go to create 3D object plane. I'm going to lower the plane to 0. Then I'm going to raise the drone up to the height I want of 1. Oh, 5. Yeah, I think that's pretty good. There we go. So obviously this is what I've got right now. Then I'm going to click on here, and I'm going to scale this to 10 and 10 just for now. I don't think it comes with any default materials built in, so I'm going to get a material off the asset store. So let's go back to it. A material, by the way, is like a texture, but it has a bit more to it. Materials can have other properties, but essentially, it's, you know, in this case, I just want a texture. But I'm going to go here for ground. I'll do like rock floor material. Obviously, I don't want to pay as well, so make sure I put it to free. I'll probably will find some lots of good materials. Which I like really. I mean, have a look. Maybe this one. Really good. So I'm going to download this stylized stone texture, add it to my assets, accept it. Okay, so I can open in Unity, open editor, and that'll actually take me straight to it here. So I probably should have done that last time, really. Press download and then import, and then I'm going to drag that onto the floor. It's not very difficult to do. If you're following, obviously remember that you could pause this and do it. I'm going to bring it all in. So a material, because like here, I will talk about this later, but diffuse is about a type of a lighting and about reflections and things like that. So material can have things like reflectivity and all other things, as well as just what like the texture. As a texture is just an image, like like other things could be like how much light does it reflect off? You know, like how much bounces off of it. Did I actually bring that in? I did. So let's go to materials. That one. That looks pretty good, but the scale of the material looks off. So I'm going to go here. So I've gone to the plane that I've dragged the material on. Obviously the material is massive. So I'm going to go here to where it says tiling. And I think it's this one. I'm going to 0.1. And I'm going to go in here. Nope, the other way around. I'm going to go 10. 10. There we go. And that looks a lot better. Probably could go even higher, actually. Yeah, I'll go higher. Let's go. I think it might even be the case here. Yeah, I mean, I don't like the floor now. It's on the floor. I don't really think it actually was floor, but anyway, it'll do. It'll do. We're only doing a mock game. We could obviously whack in a metal floor or whatever floor you want, and we can do other things, put rocks in and other things on top as we go. But hey, we're just messing around right now. So here is the game. There's my little dude on there, and so we've got it in. So that's out the first bit. Okay. Right, now I was originally going to show you how to use the third-person controller built in, and I think I will in a different video. But because I want to introduce the basic techniques of Unity, I feel like it's better if we code everything ourselves from this one. So I've changed my mind a little bit. I'm going to get us to fly this around ourselves, and then I'm going to later on show you how to use the built-in controller, which is quite good. But at the same time, it is quite fiddly, and it's not really, it's just like a setup process. You could watch a lot of videos to do it, to be honest. I could just link to a really good one online. But the point is that I want to teach you how to use Unity, so I'm going to just go back to doing it ourselves. So I've got my character that I'm going to call drone, whatever, and again it's just playing like this. So what I want to do now is add the ability to make the drone move around, and then I want the camera to follow the drone around, so that we can fly around and using WASD, and then it will move around on its own. So what I need to do then is create a script. So I like personally, I'm going to actually, to make folders for this, you don't have to. If we call that drone, hope it doesn't break the game. Sometimes they have a link to the path. So I'm going to call it drone, and I'm going to create a folder called scripts. So create a folder called scripts, and I'm going to create one called player because it's good practice. Now, when you watch a lot of videos online on Unity, and I have seen a few, they actually often teach you really bad things. They'll often instantly go, right, let's create a C# script called player controller that's going to do everything. It's going to shoot, it's going to do your health. It's just really not a good idea. Like, you're not really supposed to have the scripts do everything. They really should be doing like their one job. It's just good object-oriented practice that they sort of have their one thing they do. So we're going to have one called player movement, have one called player shooting, have one called player damage, have one called what player collects things, whatever we call them. But it's good to break them down because it's good. It's how it's done properly, and it's just good decomposition, isn't it? You're breaking it down into small jobs. So I'm going to call one called player controller, but it's going to be the controls only. So player, I'll call it player movement. Actually, there we go. Movement. Now that's not attached, so I'm going to go. It'll take a few seconds to create it. So I'm going to go to the drone here, and I'm going to drag the script onto there. Now I've got the script here. Okay, and I'll minimize all these so you just maximize. So you don't have to see them all. You can order them round. I think I can. How do I move it up? I move it up? No, it doesn't look like I can. Anyway, so I'm going to double click on the script there, and it should load Unity at Visual Studio. Go. And it'll load up here, but I'll bring it over in a second. There we go. So I've got my scripts here. Okay, now it's C#. Okay, so it's a class straight away, and the class is called player movement, and mono, it inherits from mono behavior. And so basically Unity's got this thing called mono behavior, which means that things are going to have like events like start and update, and we'll talk about that more. You can create normal classes in Unity that don't inherit from mono behavior, and they're just normal classes. It's not as common as you would use outside of it because of obviously the ability to create objects that do things rather than requiring a class. You could literally create an object that does something, and that would fit into more Unity style. But you could create classes to do things as well. So how the events work, I'm just going to try and see if actually quickly I can get up on Google a picture of the Unity event order. If I'm getting it. There we go. So this is it. Boom. So we've got these events, okay, and they trigger. Some of them trigger when the object is like made or destroyed. Okay, so awake. If you or sleep an object sort of thing. Awake is going to be the first event to be called. Then on enable, then start, and then it will call these in a loop. These three in a loop. So it's really badly drawn, really, because these three should be looping like this, because these are looped. And then when it's destroyed or disabled, it will call these in that order. So this is when it's created, and if it's re-enabled. So you can enable and disable an object. So awake would be for the things that you only want to happen like at different times to enable. But don't worry too much about that now. But I just want to know there's an order to events. Probably that's a bit confusing, really. Maybe I shouldn't have bothered. So start is an event that happens before the first frame update. So if you want to do anything like set anything up, you might put it in start. An update is obviously called once per frame. So that's where you do your updates, including player movement. So because Unity is an editor, we need to create some variables, but we want to create them so that you can edit them in Unity. So it's a very strange thing that you do, but you write this thing called serialize field, right? And what that will basically do, it does other things, and we'll talk about it later, but I'm going to keep it simple. Essentially, for right now, it's going to mean that even though I'm going to make a private variable, I'm going to make a private variable called like player speed. I want to set it to a float because otherwise it's stupid. And I'm going to set it to 10f. Doesn't really matter what I set it to here because I'm going to change it outside of here. This is just a default value unless I change it. If I change it in the editor, it will overwrite whatever this is. So this is literally 10 for now. So in fact, if I save this and then go back to Unity, excuse me, you'll see here, oh, it was there just a second ago, that I've now got this thing and I can drag this slider, I can type in the speed, and I can do that live as well. Now that will be 5 now forever. That 10 that I put in is gone really now. That's just, although if I added the script again, you'll see that it's 10. So it's the default, but as soon as I change it, that 10 is gone forever, right? So that's what serialized field does, okay? If I make a variable public, it will also appear in here without the serialized field. But obviously you don't want to make variables public, especially not here, because the fact is you're going to change them using the editor, so that's even better. You get sort of best of both worlds. So I'm going to do player speed, and then obviously that's going to be our movement speed, okay? Every object has like position, or every mono behavior object is going to inherit some things. So I don't know if we can actually go to the implementation. No, we can't. It would be complicated anyway. But all objects that import from mono behavior have like transform, things like that. So we don't need to store our position or our scale or our rotation, because they are going to be already there for us to edit, which I can show you in a minute. Right, so I'm now going to talk through the code that I've just put in for the update to go forward and backwards. This is actually incorrect because it's going to go forwards and backwards, not well, it's going to go down the z-axis and not where the player's looking, but we're going to fix that as we go. I just want to talk you through this in case this is confusing. I wonder if I can. So I'll just play it and show you what it does. I'm going to press W and S keys. W. There we go. So we're going forwards and backwards down the Z axes. Right. So if we look here at this code, so we're checking to see if W is pressed. If it is, transform.position is that transform.position. So we're literally saying edit these variables. Okay. We're going to add a new vector 3, right? Because this is a vector 3, we need to add a vector 3 to it. We can't just add. You can't do, it doesn't let you do like .z plus equals. It doesn't let you do that. You can't edit a single element of the vector. You can access it to look at, but they're read only. So I can't change the z value, right? I can only change the whole position. So I'd have to, if I wanted, so here I'm adding to the z. Yes, that's how I do it. So I'm creating a new vector, which has that in it, 0, 0, 1. Okay. Then I'm timesing it by the player speed, some sort of speed variable, and then timesing it by time.delta time. Now, time.delta time is basically how long in milliseconds or millions of seconds, whatever, decimals of seconds to really high accuracy, is it between the frames? Okay, now I actually can console log that, so you can see it. Although just to be clear, doing different things, debug.log. Actually logging this will actually slow it down, but not long. But you can see that it's going to be, the FPS is high, right? So if we go to the console, so yeah, look, I mean, we're talking thousandths of a second. So it's timesing it by that to basically adjust for how quick the computer is. Okay, if we didn't do that, then the game would run different speeds on different computers. Right. So anyway, I don't know why I minimize that. And sorry, if you didn't know, that's how you can output things to the console. Obviously, I should have mentioned that. So you can type debug.log. You can also just type print, I think, now. They allow prints, I think. Yes, you can just write print. I've just got so used to doing, I'm pretty sure that works now. I've just got so used to doing debug.log because it didn't have print for a long time. I think it does the same thing. Yeah, so you can just do print now, but I'll probably keep doing debug.log because of habit. But there you go. So, right, anyway, there we go. So obviously I've got the -1 for the S. What I mean by this is wrong is no matter which way I'm facing, this will still go straight up and down the Z. But we'll get to that point when I go through the next part that I'll quickly code and bring up. So you haven't got to watch me do it, and I'll talk through it. Right, so I've added this code to do the rotation. Now you might think that why isn't rotation very similar to this? Why wouldn't you just do the same thing with the rotation values and edit them? And the reason is that, because you could just edit these, why is it not exactly the same code, but instead of transform.position, transform.rotation? And that would make sense. Except rotation is very tricky in 3D. I won't get into the details of why, because it's quite complicated, but they don't actually use X, Y, and Z. They use quaternions. I think that's what it pronounce it. And basically this avoids something called gimbal lock, which you can look at, and it's about, so there are certain degrees that don't rotate correctly if you just use an X, Y, and Z. So they use a different quaternion. Yeah, quaternion. It's a you can read about them. They're apparently a more accurate way to do rotations. Okay, so there you go. It's quite mathy. You can look it up. So Unity provides functions to rotate. You can convert between what's called Euler angles, which are these ones, EULA, but they provide a function to rotate. So why not do that really? But yeah, I mean they also provide functions to move, but I wanted to demonstrate the way of doing it properly. So anyway, so I just wanted to show you the different ways of doing things. So transform.rotate. Okay, note the capital R. We do a new vector, because this one's going to take an Euler angle there, EULER angle. Okay, it's got different overloads here, so there are different versions of rotate that take different parameters, but I'm just doing one that takes a vector 3. So I'm giving it a vector 3. I'm rotating on the y-axis, and negative for A because it wants to move anti-clockwise, and positive for D to move clockwise. And of course, I'm multiplying it by time.delta time to get a correct speed. Now, I've created a turn speed variable. It says 20 here, but I found very quickly 20 to be nowhere near fast enough. It's actually 75. I'm going to increase my movement speed. Remember that these are default values at the top, and once you change them in the editor here, they obviously take these values. So these are the values that I'm actually using, 10 and 75. Although I think I was using 5 before, so I'm a bit rapid now. But this is what I was saying before. See, look, I'm not actually moving in the direction that I want to go. I'm rotating. I don't actually even like that speed. I might actually make it 100. Just one thing, any changes you make in play mode, like now, won't be saved. We'll go back to 75. So I need to make that there 100. It does annoy me that I wish there was a button you can click. Maybe there is, I don't know it. It says like lock all changes, but they don't do it by default anyway. There's my little drone spinning around. But as you can see, I'm just going up and down the z-axis, and that's not what I want. Okay, so we're going to have to edit our code to not do that. Right, so thankfully, Unity provides us with a handy way of getting the vector of what forward is compared to current situation. So you just got to change these two lines to transfer.forward, and that will allow you to, so the forward will now be the real forward. Rather than going down the Z, it will be wherever the forward is. Actually, I could print that out so you can see it, actually. That'd be quite handy. It's going to be what's called a normalized vector, and I'll explain what that is in a second. It'll be easier to explain when you see the numbers. Let's print transfer. I wish I would stop doing messing it up. Anyway, there we go. So let's play and make that bigger, go to the console. And you can see that at the moment, my transfer.forward is 1 because we're facing down the Z-axis. If we rotate, you'll see that it's changing to see, whatever direction that is. How handy. Look at that. It's flown off into wild and beyond, God knows what. So, so now theoretically, our program works. Actually, if I was to make the camera in a bit better position, actually, up and then really rotate it, let's make it sort of semi-top down. Where the hell are we, though? I went really far there. Let's lower that a lot. Let's do 100. Why is it now? Hard to visualize where it is. There we do. Terribly done by me, but get there. Right, so yes, now we can see. Cool. We've got a little shadow showing from our directional light. Off we go. Look at us go. Now, what we really want is the main camera to follow us, and so I have a feeling I have messed up my forward because I need to do -1 for backwards. So I need to do. Is there actually a backward? If not, just do forward, and then I can just do times -. Or I could do minus. Actually, I just do minus. Going to be mathematically the same thing. So there we go. Minus transform times planar speed times time by delta time. Because my backward was going forwards. There we go. Look at me go. Oh, we've got a little game going on. If we could shoot, we're halfway there. So anyway, there we go. That's the current situation of it. So let's get it so that the camera will move with player. So I'll do this a bit more live because then you can see it. But there is a slight issue you're going to figure out in a bit, which I will also demonstrate as a pain to solve, actually. But there we go. But we'll show it in a bit. So let's do a bit more live, and then I'll have to go here. So I'm going to create a script called. Let's make one folder camera. Folder called camera. I'm going to create a script called camera follow. Now probably I could just Google for a script, but I'm going to create one anyway to show you how to do it really. But I'm gonna have to look at some of it because I really can't remember how to fix the problem. Well, I can, but I'll take ages to solve. So I will just look it up. So here is the camera, right? So we've got start, update. This is where we're going to put all the stuff. So obviously we need a thing to follow. So how do you know what to follow? Well, this is what you do. You do game object in here and you put like object to follow. Right, so if I save that, I've made it a serializable private. It'll be public if I don't put that. It doesn't really matter, but good practice as always. So if I come back out here and go to the main camera and then add the script, okay, I can actually drag in a game object now. Look, I've got a game object, and what I can do is I can drag that in. Boom. And now, when I'm in the script here, so let's set our positions. Or I'm going to do an offset because you don't want the object, like how far behind the object you want it to be and stuff like that. And don't get me wrong, I bought a camera controller that you can download, free ones. They can be quite annoying because do you want to smoothly follow it? Do you want to perfectly follow it? There's all this sort of stuff, smoothly follow towards the situation. It depends on your look. We're going to keep it simple. We're going to make an offset. There's going to be a vector 3. Although really it just should be a distance from behind, really. Actually, that's just do a float. Oh, no, we do want an offset of vector 3 because we don't just want to be behind it. Vector 3, which is offset. So this is going to be like, what's the difference? I'll show you now without the offset, and then you'll see that we're inside the object. So a really simple crap way to follow it that isn't going to work properly. The object would be transform with a lowercase t dot local position is equal to object to follow local position. So we're dot transform dot local. So I'm basically getting. I'm saying let's let our position be equal to the object we're going to follow's position. And as you can see, there we are. We are following it. Let's go around. The camera is following. It's looking down at the floor, but it is following. So if we were to get the camera, we're on the camera and set the rotation to 0, 0, 0, 0. Set positions to 0. Not that it matter because we're going to instantly follow the object. We'll probably be inside the object and thus, oh no, we can see stuff. So we've essentially got some sort of first person. But the difference, well, you can inside the object, but so you can see the problem is though, we're not rotating with the object. The object's turning. We're always looking in one direction. So let's add the offset anyway to show you what offset would do. Offset's going to allow us to go plus offset. Then we're going to save it. And then we can do like we can play it and then run the settings until we get what we want. So we can, we probably do want a bit more of the Y, maybe like 1. We definitely want some Z. 3, no, -3, -3. Yeah, there we go. Something like that. I might rotate. Now, probably it's going to forget those. So I have to remember them. 0, 1, 3. 0, 1, -3. My tab key's not working. I've had to order a new keyboard. -3. And we probably want to rotate our camera down a bit. Just a little bit, even just a small angle. Because we have raised ourselves up. There we go. Look at that. Looking pretty good already. But again, of course, we're not doing it. Now, you have noticed that it's quite jittery. That's interesting, isn't it? So really, what we should do is, because of the order of movement, we should put this in late update. Because what will happen is, then it will be called at the end of after the movement is done of the player. That should fix the jitteriness. There you go. Because what was happening there is, theoretically, the camera was updating before the player was moving or vice versa, and not even the same. So now we're doing late update. We're going to set the camera's position after all the objects have moved, and it stops the jittering because it's the order of that scripting I was telling you about. Late update comes after update. So you can see how handy those different orders are. So brilliant. This is great. However, we want to be back here. We want to be back here, which is quite annoying. So we need to set our position differently. We need to set it. It's going to be fiddly. I could figure it out myself. You know the forward position, okay? And this is our offset, what we want to times it by. So we want to set our rotation equal, first of all. So let's set our rotations equal so that we're facing the same way. Right, but that's not the same as fixing the problem, which we'll see in a second. Because it's our position that's the problem. We're going to have to use the forward and actually move ourselves backwards. Because now when we turn, the ship is turning and we're facing the same direction, but we're not behind it. We're always in the same position. If I go to the game scene, it'll probably be, if I focus, zoom in. Now, it'll probably be, if I then go here and turn here, we're always this distance away. We're always down the x-axis away. So what we need to do, right, so after a little bit of fiddling, I decided to make a few changes. I got rid of the vector 3 for the offset because I wasn't going to use the ZX offset. So that just seemed odd. So I've just got distance above, distance behind. I've done a bit of Googling, but also, to be honest, the code I found was wrong. But I just wrote it myself in the end. So I realised what I had to do was, now it's a bit complicated, but you don't have to understand all these things. You know what I mean? Like in reality, you can just take them. But what I'm doing is, you want to know, I'm getting the position of the object to follow in a variable called temp. Then this is the bit that does the distance behind. So I'm getting the forward vector. So that is how much it faces forward as a vector. I times that by my distance behind, which is 3, and then I deduct that from the positions. That's going to move us back 3 units, okay? And then I take off the object to follow transform up. That's just going to give us up, which is, we don't rotate anyway, but I mean, it doesn't matter, but up. And then that's multiplying by the distance up. So that's the bit that does the up part. That's the bit that does the back part. And then I set our local position to what I set to temp. I could do this all in one command, but obviously this would be a terrible code. And then there you go. So I've got 3 behind and 1 up. Should be an F there, just for a good practice. And there you go. So now if I play the game, you can see that, yeah, I'm flying around. There you go, like this. Whee! And brilliant stuff. Now, annoyingly, there is one bit of the code that actually is irritating because it ruins my angle down that I set my camera to, because it will always just follow the rotation of the object. So, I mean, you might prefer that. I wanted it to be a bit more facing down. So as we only rotate on the Y, I'm just going to only use the Y. And so because of that, I have had to change the code to this. So I'll just explain what this does. So annoyingly, because the rotations are all stored in those quaternions, I need to, and I can't edit them directly because they're confusing and weird. So I need to turn them into vectors. So I get our rotation as a vector 3 in X, Y, and Z rotation. I get the object to follows rotation as an X, Y, and Z. And then I use this transform.rotation, and essentially this will convert our Eulers back into quaternions, right? And it takes an X, Y, and Z. So it's a little confusing, but I get our one, I get their rotation, and then I pick which ones I want to set. So I'm going to use our X. So no matter what the ship's X rotation is, it won't affect ours, which is going to allow us to look down. Okay. The Y we're going to use of the objects that we're following, because that's what we want to follow. We want to follow the left and right rotations. And the Z, we're going to use our one. So we're going to keep our X and Z rotation, but use their Y. That's what that basically does. So if I now play it, you will see that I've put an X rotation of 25. So I mean, I can make that higher. So we'd look down. I could also adjust my above. You know, obviously these won't get saved, but I could just remember them to, you know, whatever. And then I've got a different style of game. Whereas if I didn't do that, it would copy all 3 of those X, Y, and Z. But now I can tick which ones to follow. And I could even put Booleans down here. I'll show you that actually. I could just say like bool rotate X to a serialized field, obviously. Private, because I'm not a monster. Rotate X and set it to default as false or whatever, and then do rotate Y. And actually it's good because I can then actually teach you Lambda expression. at the same time. So why is my Z not working? My Z keys, my keyboard is actually broken. I'm not joking. I've got two keyboards, Corsair Strafe and a Corsair 55, and both of them are broken. I've got another Nafia one, but I've ordered another one, but it's so annoying. Anyway, so this will appear in here. Okay, and I could select if we wanted to follow the rotations of the object, like this. And how I would do that in code is down here under this bit, I would go like, I could do a choice here. I could do like rotate X like this, and then do question mark. This looks confusing. If it's true, that means we want to use the object to follow one. So we would use object to follow .x, and if it's false, we use our one. Now I'm going to show you this because it looks mad. You're like, what the hell is this? My tab key is also broken, so I can't tab it. So I'm going to show you what these is. This is a Lambda expression, and it's using normal C. Should have had a comma there, of course. And I'm going to put the last one in for the Z. Paste it and then delete this. So X. Let me just type it in. Make sure it works, and then tell you about it. Z key's really struggling. Look, you can hear me pressing it. Oh my god, I can't. I don't know. I think my shift key's broken on this keyboard. Anyway, so bad. So right. So what Lambda expression does is you can do a test. Now because this is Boolean, we can just do it, but we could do something like age greater than 18, right? But obviously because Control Z, because it is a Boolean, we can just use it. So if this is true, then the value will be this. If it's false, the value will be this. You can use it for things like, let's say you wanted to say like in age equals 0, right? There you go. Age equals 5 greater than 7. If it is, set age to 6. If it isn't, set age to 10. And that's what Lambda, well, there are other things Lambda expressions can do, but that's one of them. And it's quite useful in situations like this. So I'm going to pick between two variables based on a Boolean. It's perfect. So now, if I save that, I know it's a bit complicated, and if you didn't get that, don't worry too much. That was just me, deciding to teach a little bit more at that moment because it was a good moment, because that is how I would code it. And so I want to teach the people who are watching this how I would code it properly. Now, if we're heading along, you notice now I'm not even following any rotations now because this isn't ticked. But if I click that, bang, now we're getting exactly what we want. If I click the X one, now we're going to follow the rotation exactly. And Z's not going to do anything because we don't rotate in Z at all. So it's not really useful. But hey, it's still there if you wanted to. But you can see how I could, do. This is quite a useful script now. You could just call this object to follow. It's not even about a camera anymore. It's just a useful script that we could use in other places. And you select whether you want to, which rotations you want to copy. Now, I know I've unticked that and you're thinking, why is it not going back? The problem is it doesn't set that back to normal. It just means it's no longer following. So we'd actually have to set that back to 25. But there you go. So you can see that that's what a Lambda expression is. And now we've got the ability to turn on and off there, whether we want to rotate it, and everything's tickety-boo. So I'm going to stop there because I think the video is already about 7 hours long. And tomorrow I'll probably record the video for doing shooting, collecting, how to talk to each other in scripts. So for example, how do we get a script to talk to another script? Because that's important, because we're going to have on our drone, we're going to have like a collecting script. And I want the collecting script to alter a variable in here that's private. So we'll obviously make a method to allow that set and get, or we could do other things. But we'll talk about that tomorrow, and good luck.